Hi guys, let's start the second session of March 11th. Previously in the previous session, I tried to understand this problem, and then so the algorithm is like the problem gives us this range, and by traversing each node, if the node is in this range, inclusive range, then we'll add the value into the sum. And then one of the point is that if a node is smaller than this, then you don't need to go through the left node. Likewise, if the node is greater than the high value, we don't need to go through the right node, right? So let's write this. So the base case is that if node is null, is the base case. If node is null, then it's nothing, so we just return 0. And if and then if node is in the range, which means that lower, because it's inclusive, we can write lower node val and node val high. If in this range, so here's one thing I am not sure about, is that is it really so for example, in this case 715. Oh, so the higher node is smaller than this, and also not in the range of the low and high, but so this does not contain, but the left node contains into the sum, calculation of the sum. So in this case, so let's define int sum 0 here, and then if in this case sum is node val, sum is node val, and then if node is not in this range, sum is still 0. And then what we are gonna do is that if left node and so here we have node. So node value is less than let's say low, then we're gonna skip the left node, which means that if this is bigger than low, then we're gonna add sum equals plus DSP node left, and then low high, right? And also, if node value is greater than high, then we are not gonna go through this. So that means if the node value is less than high. So here is 715. So here 5 is less than low, but it has 7 here. So this is actually not true. Oh, this is true because high is, in this case, this is smaller than high, so we're gonna go through the right node, right? So, and then gonna go through the right node. So this is the right. And then we can return sum. And let's think again. If the value is lower than, yeah, in the case, yeah, maybe instead of this, something like this will be easy to understand. And also if the current node value is larger than high, we don't need to go through the right node, but if it's not, we have to go through the right node, right? So I guess this is it. So here there is exactly 1 to a lot node in here, can be here. So the test case we can consider is initially something like root node. Yeah. In this case, well, let's say that we have root node and then like something like this, or we have root node and then maybe something like this, or we have root node and something like this. So in the first case, this is the normal case, so goes to here and this is correct. The sum is 1 and node value is not less or not greater. I mean node value is, so this and this will be called again, but it's 0 inside this and this, so 1 will be returned. And then here sum is 0 and this is false, so sum is still 0, and 1 is not lower than this, right? So we'll go through this one, but it returns 0, and then this one is higher, right? But it says not higher, so we're not gonna run this, so it returns the same, it turns 0 in the end, right? Then I guess this is also same, everything is 0, so let's go through this. So initially 10 is, node with 10 is added, and then the value, the low and high is this one, so 10 is in the middle, so sum is 10, right? And then 10 is not less than lower, 10, this is low is 7, so this is false, so in the end this is not, so it's hard to debug. Let's fix again. Yeah, maybe doing this not is not a good idea. And then my brain actually works like this. What the hell? So low is less than 10, so we're gonna go through this one, right? Now the node is 5 in the new DSP call, recursive DSP call. And then this is false, right? And then 7 is 7 and 5. And then 5 and 15, so this will be called, right? And then this will be called, and right is now 7, and then 7 is in between 7 and 15, so sum is 7. And then these are the null node, so anyway they are 0, so 7 will be returned. And then so 10 plus 7, and then inside this call, inside this DSP with this node, it has here 10 is smaller than 15, right? So this will be called. And then right now this 15, so in the new recursive call with the node 15, this will be true, so 15 is now, sum is now 15. And then 15 is greater than this, but this is null, so this will be 0. And then this is 15, yes, so let's go to this one, but it's not in here, and then the node of these are null, so this will actually return 0. So the sum here is 15. So in the end, sum will be 7, 10, 15, right? Okay. Yeah. So this also can be solved with BST, right? So the logic could be also similar. Like let's, before doing that, let's think about the time. And time complexity is that normally it goes through everything. Yeah, so it's overwhelming. And some could be omitted, but basically in worst case everything need to be, searched. Well, if the range is pretty high and pretty low range is low, high is very high. And then space complexity is it's like a O of h, where h is height, right? And then in case of BST, this is T. Yeah, it's traversal. BST. So the way BST works is always it start with Q, and then we'll put Q, push the root node, right? And then while Q is not empty, we run some, we have some 0, So auto, let's reuse that node. Node Q front and then Q pop. Let's pop it, and then it's same, right? If this but in here it will be something like this, and in here what we need to do is that we need to push node left, so the node on the left later will add its value if the range is correct, and then node right. So they are keep adding their value if they're in this range, and then after all, at the end we can return sum. If node is this range, so node with the value 0 will be queued, and then it will be popped here, and then the value is now 1, right? Because the range is in the range, and then what we need to check is that if node left must be not null. So, and then blah blah blah, then we can do this. Yeah, BST. Oops. Tree. Oh, Qst. Maybe I played the game too much. Yeah. Cool. Okay, so I think this is it for this question, this problem, 938. What is the point to learn with this? Normally range is not given with the problem, but this is given with the range, so we have to check whether node is in the range. If a node has the small value, smaller than low, then we don't need to go through the left node. Likewise, if node is greater than high, then we don't need to go through the right node. So I think that's the point. Thank you. Bye.